Of course, water is part of life as we know it here, and even when NASA and other agencies from Europe go out of, the into space, they look for life. They always think maybe water is a very important element, key component for life. So you want to understand the properties of water, and we're starting by saying weird water because water has some unique properties. Of course, on Earth we have it as frozen in glaciers and water vapor in the atmosphere, and we have water in the lakes and rivers and so on. So it is in all its forms on Earth naturally. So you can now put some ice cubes in a glass of water, stick some tape at the exact height of the water level. The ice cubes should stick up above it because it floats. What will happen when the ice cube melts? Will the water level rise? Will it fall? Or will it stay the same? Okay, it's going to take a while for it to melt. You might as well go on reading in the meantime. And you can see here subtly that the ice cube is mostly underwater, even though it's floating. Only about 10% is sticking out, and this is true in the ocean as well. When that big massive glacier was sticking out of the ocean and the captain of the Titanic saw it, he knew that was trouble, because what was outside the water was only 10% of what was below it, and what's below it could do serious damage to what's below the water of the ship as well. So he was a smart man, but unfortunately the ship was moving too fast and he couldn't get away from the glacier. Okay, so that's the property of the ice. When it freezes, the water molecules get arranged in a way that its volume increases, and you know that density is mass divided by volume. If volume increases, mass divided by volume decreases, so density decreases, and lower density things float in higher density fluids, right? So that's simple. You probably already know, and you think, why is this old man telling me that? Well, the ice cubes are just like ice floes and icebergs. They stick up a bit above the water, but most of them is below the surface. This is because ice takes up more room than water, so the volume is higher. When water freezes, there is more space between the water particles, so the molecules get arranged nicely and create a lot of empty space, let's say. This means that it expands and keeps floating. The amount of ice above the water is exactly the extra space that the water needs. So when you freeze it, that's how much water extra space it needs. So it stays in the water to the extent that it used the same volume as before and sticks out for the extra volume that it used up. Okay? When ice melts, extra space is no longer needed, and so the water level remains the same. So the water level, you can see here, remains the same, doesn't increase, doesn't decrease. Okay, just take a look at your glass after finishing reading and coming back, so you can see what happens. You can also do this experiment the other way around. Fill a sturdy plastic cup with to the brim with water, put it in the freezer and wait until it's completely frozen. Now the ice will come up above the edge because it's going to expand. Not a drop of water has been added, and yet the water needs more space. If you let the ice melt, it'll fill perfectly into the cup again. So when ice melts, it also has no effect on the sea level. Okay, this is a strange feature of water. Almost every other substance shrinks and sinks when it goes from liquid to solid because the volume decreases. Water expands and floats, but water has another peculiar feature, one that does have an influence on the sea level. In addition to keeping up more space, in addition to taking up more space when it's frozen and solid, water also takes up more space when it's over 4 degrees centigrade. For every extra degree, the water expands a little more. This is true for all water at 4 degrees and warmer. You expect warm water to expand and have more volume. It's just funny that when it freezes also it takes up more volume. So that's the weird part of the water that we are talking about, right? So that's just about every ocean and sea. Then to a depth of a kilometer, the sea level rise is not only because of the melting land ice, but also because warmer water also needs more space. So we have always had these stories about message in a bottle. So you put some message in a bottle and seal it up and it floats on the water. You throw into the ocean, it goes around and somebody else gets it and opens the bottle and looks at the message and sends you a reply. And the fish here is looking at the ocean warming up and increasing in volume. It's hard to predict how much water will rise. There could be there could come a point, for instance, when the melting of the Greenland ice cap can no longer be stopped, so it will keep accelerating the ice albedo feedback will take over, and the warming has reached a stage where it will just continue till all the ice has melted, which is what is expected to happen soon to a glacier in the mountains of Venezuela. In that case, the entire layer of ice will disappear into the sea and the sea level will rise all over the world by 7 meters. 7 meters. This is not something that you will experience unless you are taking immortality pills. Okay, so that will take some time. In 2014, the IPCC thought the sea level would rise by a maximum of 1 meter this century, but there have since been reports that it could be double that, so maybe it will rise by 2 meters. That's quite a difference as well. It also matters where you live. If you are living in Bangladesh or in Manhattan, it can matter because not only because more water is coming onto land, but when the cyclone comes, it's going to sweep in much more water onto land. That's because the surface of these seas is not perfectly smooth. It's actually more a hilly landscape as a result of currents and because of differences in gravitational force. Large land masses attract water just as the earth pulls the moon and sun pulls at the earth. Even the ice caps of Greenland and Antarctica have so much mass that they pull water toward them. If the ice cap melts, the mass will decrease and more water will go to the other areas. The land will also rise a little as there is less ice weighting it down. So Greenland and Antarctica themselves won't suffer too much because of the rising sea level. So you can see that the water level is not flat, even though we call sea level, it's dipping somewhere and it's rising somewhere because there is an island here and the land has mass more than the water. Then it pulls the water by gravity, so you can see water rising towards it, and it sinks away from the land, and there's a little island here which also has some gravity, pulls the water up a little, and the fish is looking up and trying to avoid this bird that's trying to catch it, so it has to go under at higher sea level and so on, right? So I hope you understood that when you put on a lot of snow and snow and snow and snow and keep building glaciers several kilometers thick, you know the water has a density of 1000 kilograms per meter cube or 1 gram per centimeter cube. You're putting a lot of weight on land, and you know that land is kind of bobbing up and down on the material below the mantle that is not solid rock, so it can sink. So glaciers can make the land sink. When the glacier melts, the land can rise, and there are other details as well. Okay, so this is all very nice. Okay, so if glacier is pushed Antarctica down and glacier melts, then Antarctica will go up, so it will not experience the sea level as much as Bangladesh that is sitting there quietly. So you can see glacier pushes the land down and the land ahead of it rises. So if glacier builds on Canada, then parts of the US, let's say New Orleans, will be pushed up, and parts of the land that are under the glacier will be pushed down, and when the glacier melts, that land will come back up and this land will come back down. There are other regions that the rise and fall in relation to the sea. During the Ice Age, north of Great Britain was covered with ice. Now that the ice is gone, Scotland has risen a little again, and like on a seesaw, the south of the island has gone down a little now that the heavy ice has disappeared. The east coast of the United States and the Great Lakes are now on the other end of the seesaw, so the land is sinking a little bit. Glaciers melted and made holes. When glaciers grow, water is going to seep into everything and freeze and crack open everything and create big gaps and lakes, and when the glacier melts, it's going to fill up those gaps and create the Great Lakes, and land is sinking as well. Land is sinking because it was ahead of the glacier, and glacier melted away and the land is coming down. Okay, so these are interesting things. We'll come back and talk about rivers in the sea. How are the currents moving water around? You can think of big rivers. There's a big ocean. Ocean is not sitting quietly. There are currents, of course, but sometimes the currents are concentrated and they are taking water around like a river that's flowing in the sea. We'll come back and discuss that. Okay, so remember the weird properties of water. If you're old enough, you probably learned a bit about this already, about the hydrogen bond and how evaporation breaks the hydrogen bond and takes the energy from the ocean, and when it condenses, it releases that energy, and how hydrogen bonds give it special properties, the high surface tension, the capillary action that the plants use to lift the water from the roots to the leaves by tens of feet sometimes, and so on and so forth. Okay, we'll come back and talk about the rivers in the sea. See you.